In this video, we will go through the main ideas for finding the least common multiple for a set of rational expressions. We'll start with a numerical example, 17/24ths and 19/60ths. Now, when we find LCM, it's the same as finding the common denominator. You might have done it in certain ways when working with numerical fractions, but we will focus on a very specific way of doing it that we will use when we start to look at rational expressions where the denominator is some polynomial. It starts with making sure that both denominators are factored. So the numbers we're looking at, the prime factors, we'll use these trees to break down each denominator into prime factors. The 24 we found 2, 2, 2, 3, and from the 60 we've got a 2, 2, 3, and 5. When it comes to building the LCM, we need to use every type of factor that we see. So definitely we'll be using 2s and 3s and 5s, but the question is, how many of those factors do we need to use? Well, you need to use each factor the most number of times you see it in any one place. So what that means is, if we're thinking about 2s, in this list we see 3 2s, but in this list we see only 2 2s. So we go for where we see more. This list has the most. It has 3 2s, so we need 3 2s. And then we'll move on and think about each of the other factors. Okay? So now we think about 3s. This list has 1 3. This list also has 1 3. So just 1 3 is enough. We wouldn't want to think about total, so we're not thinking, well, there's a total of 2 3s. It's just about the most we see it in each denominator. This denominator has it once. This denominator has it once. So only once is enough. And lastly, we have a 5. There's a 5 on this side, no 5s over here. But the rule that tells us that we go with where we see it most, right here, we use 1 5. Now we can multiply all these factors together to come up with 120. And we'll see in our examples when we want to multiply things together and when we want to keep them in factored form. But that's going to be our approach for finding LCM, which is really the same as LCD. LCM, we're looking at the LCM of these two denominators, and then when we go to use it in a problem for adding and subtracting to make a common denominator, that's when it becomes an LCD. And LCD is just a more specific way that the LCM is used, but they really mean the same thing. Now let's look at an example where we have some numerical coefficients and also some variables. We'll take the same approach with these coefficients. We can take prime factors of prime factors of 12 is 2, 2, 3, and prime factors of 20, 2, 2, 5. And if we start to build the LCD, we need to use some 2s. Think about how many 2s will we need in this LCD. This list has 2, and this list has 2, so our LCD will need 2 2s. And then how about 3s? 1 3 on this side, but no 3s over here, so we need 1 3 and 1 5. Now let's talk about the variables. We're using the same idea. So think about, what does x squared mean? It means we have x times x. So there are basically 2 x's that are factors from this denominator. And how many x's do we have in this denominator? 4. And we go with where do we see the most. So 2 on this side, 4 on this side. Here's where we have the most. We need 4 x's, and we can just go for the shortcut x to the 4th power. But we do need to use every type of variable we see, so we'll need to include some y's also. There are 3 y's on this denominator, no y's over here. So definitely there's where we see the most, and we need 3 y's, y to the 3rd power. When we get to this point, we're usually multiplying the numbers together. So the 2 times 2 is 4, 4 times 3, 12, and that 12 times 5, 60. Our LCD is 60, x to the 4th, y to the 3rd. If we look at our list of factors in the LCD, we can find each of our denominator lists in the LCD. So think about this denominator. There are 2 2s, LCD has those covered, 1 3 covered, 2 x's and 3 y's. Well, yep, we've got 2 x's with a couple extra, and we've got our 3 y's. And do we have each of these factors covered? We've got 2 2's, we've got the 5 covered, and we have 4 x's covered. So our LCD is a list where we can find each of our denominators also in this list. but we'll often have some extra ones so that both of our lists are totally covered by the LCD. Now here's an example for you to try. So just remember our steps for finding the LCD. First, make sure each denominator is factored. Then build the LCD using each type of factor, and think about, we use factors the most number of times we see it in any one place. So pause the video, take a few minutes and work through this problem, find the LCD, and then come back and we'll check out the answer. So I've started with this denominator, finding the prime factors of 40, 2, 2, 2, and 5. The other denominator, 44 is our coefficient. Prime factors are 2, 2, and 11. Have them circled. Just something that helps me stay organized, so I'm not forgetting any factors that I've found. You might want to do that just to stay accurate. Building the LCD, let's think about 2's. This side has 3 2's. This side has 2 2's. So go with where we see the most. Right here, 3 2's. We're using 3 2's. And then 1 5 and 1 11. And there are the numbers to make up the coefficient part of our LCD, but still we have to include some x's and y's. Now you might be onto a shortcut with the variables because our exponent tells us how many there are. Like that would be 1x, and that x to the fourth means 4 x's. And we always go with where we see the most, so our shortcut would be use the highest exponent. There's an x in the exponent, we don't see it, means it's a 1. There's x to the fourth, go with where we see more. Here, x to the fourth. And then with the y's, that's where we see most, y to the third. And if we multiply the number parts together, 440, and then x to the fourth, y to the third. Here's another example that's going to be a little bit different. Our previous examples, our denominators were each one term, a monomial, and that's when it makes sense for us to break the number part down into prime factors and think about how many x's or how many y's we have. But when we have two terms, you should think about a different type of factoring. You should think about, is there a GCF? And then after that, does this polynomial meet one of our patterns? Is it a difference of squares? Is it a trinomial? So be cautious now when we see denominators that have two or more terms. We have a slightly different kind of factoring that we're thinking about. So if we start with 6x squared, one term, still helpful to look at it as 2 times 3, and you can write out the x's if it's helpful, x times x. But over here with two terms, we shouldn't think xx and 2x, only if that's helpful for us to find the GCF, that we can divide out from each of those terms an x, have it outside of parentheses, with x plus 2 left inside parentheses. So two or more terms, we're thinking for factoring GCF or one of our other polynomial patterns. Okay, we're ready to build this LCD list and look at the factors that we have here as two little chunks. We have an x, just like we had x's show up here, but this x plus 2 is an unbreakable block. We're not looking at that x and that 2 as they're anything like that 2 and that x. They're totally different. Because it is in a set of parentheses, it is its own kind of factor. It's a binomial factor, and it's totally different from an x and totally different from a 2, so that when we go to build our list, we'll think of the 2's. We should use how many 2's? 1, 2, and 1, 3. If we think about x's, this side has 2 x's. This side has only 1 x. Remember, that's an x plus 2. So x's, 2 x's on the left, 1 x on the right. Here's where we see more, so we use 2 x's. And now we think about an x plus 2. How many x plus 2 binomial factors do we have? We have 1 on this side. There are none on the left. Here's where we see most. We have 1, so we need to use one of those. And when we multiply these factors together for our LCD, we will definitely multiply numbers together and we'll see a 6x squared, but we will never distribute. Our LCD should always stay with these binomial factors in parentheses. So never FOIL, never distribute when it comes to the denominator. The numbers we like to multiply together, but in parentheses we leave those alone. And there is our LCD just looking the way we want it to look.